All right, guys. First video I'm recording for Algebra 2. It's Sunday morning. Last night I recorded a whole bunch of calculus videos and 8th grade math videos, so you guys are getting the highest quality video because I've practiced with them. So we're starting with our first lesson here where we're just going to talk about key features of functions. And you guys probably remember some of this from Algebra 1. I'm not sure if we talked about it in geometry, but like what different functions look like. The domain and range. So we'll start off pretty easy. I think you guys will get this quickly. Okay, so first is I have this example of this function here, which if you remember is a quadratic function, a parabola, and we're just going to remember what domain and range are. So if you remember, the domain is the set of all possible x values. So I'll write that here. Set of all possible x values. So one thing I didn't say yet is that I'm going to be making a lot of these videos for notes, and the expectation is that you have a notebook of some sort and you're recording these and writing down your own notes so you have them. So when we have quizzes and tests, you can study and you can use them for the practice set, okay? So you should get out a piece of paper, ideally a notebook, and take your own notes. So here's the function. So what are the set of all possible x values here? So first thing I'm noticing is that these arrows mean it's continuing on forever and ever. And you can notice my sketched out parabola, which isn't very great. It's getting wider and wider and wider. So the domain of this is that you can plug in any x here and you're going to get a y value, right? It's just going to keep getting larger and larger, wider and wider. So the way, one way to write it, which is the way I think you'll see it most often, is called interval notation. So I'm going to write that here, interval notation. And the way you would say that x can be any number is you would say that it can basically be negative infinity to infinity, right? X can be any number. Set notation, this one's a little bit weird, but that's when you use the greater than and less than value, so I'm not going to write it here because x can be anything. The other thing you can say is that x can be all real numbers, right? So this is interval notation. I just want to highlight that because that's what we're going to mostly be using. X can be anything. Okay, so if domain is all the x values, then you guys already know that the range is the set of all possible y values, right? What's your output? So I'm looking at this, I can see my range is restricted. It has to be larger than -3. So if I'm writing that in interval notation, this is what's really important, is that can x be -3? Yes, it can be -3. So that's why I include a bracket. And it can be any number larger than -3, so it's -3 to infinity. Infinity always has the parentheses around it because it can't actually be infinity. It's not a number, but it can be -3. If it could not be -3, let's say that was an open circuit or open hole dot, like discontinuity, then this would be a parentheses, right? That's kind of like, this is the greater than or equal to, where a parentheses would just be greater than. And so then the way you would write that, so you can see it in set notation, would be that y has to be greater than or equal to -3, but less than infinity, right? And if you wanted to use set notation up here, I just feel like it's a little bit weird when it's set notation. For that, you would just go infinity to -infinity, which that's a really weird way to write it. This is the more common way to write that. So this is probably what you're used to from Algebra 1, but we're going to start using interval notation to get you guys ready for calculus because I know you're all going to be there pretty soon. Okay, so domain and range, hopefully not too tricky. Let's try another one. Let's try this one up here. We're going to ignore this for now, down here. Okay, so a car, move it up. A car starts a journey with a full tank of gas. The equation y equals 16 minus 0.05x relates the gallons of gas, y, to the number of miles traveled, x. what are the x and y intercepts and what do they mean? So x and y intercept is where these cross. This is when it's going to cross the x-axis, and this is when it's going to cross the y-axis. Okay, so if we want to figure out the x, when it's going to cross the x-axis, so in order to cross the x-axis, what do I know? Well, I know that the y has to be 0. So if I'm looking at a graph, I'm just going to go back to that last one. In order to cross the x-axis, the y value has to be 0. So we need to figure out, in order to find the x-axis, when is y going to be 0? So let's just rewrite the function with 0. Substitute that 0 in for y. So 0 equals 16 minus 0.05x. Now we're just using some algebra to solve this. Let's move the 16 over. So subtract 16 from both sides. This is negative 16 equals negative 0.05x. Now I know I can just cancel out those negatives. So 16 equals 0.05x. So now the last step is to divide. And I'll just write that here by 0.05 so that we can have x on its own. And x ends up being, let's write that, I'm going to just use my calculator function so you guys can see real quick. 16 divided by 0.05, 320. Okay, so that means x equals 320. So the x-intercept is the point. I'll write it here. The x-intercept is the point 320, 0. Now, what does that mean? So if it is crossing, if y equals 0, y is the gallons of gas. So that's when you've used 0 gas. So what does the x mean? The number of miles traveled when the gas is 0. So that is telling us that if we used all of the gas in our car, we could go 320 miles, right? It's kind of like the gas remaining. So we can travel 320 miles on, it's a full tank, right? A full tank of gas. That's what the x-intercept means. Okay, so now let's find the y-intercept. When does it cross the y-axis? So in order to cross the y-axis, x has to be 0. So instead of substituting in a 0 for y, we're substituting a 0 in for x. So in order to find the y-intercept, we are going to say y equals 16 minus 0.05. And now what happens if the number of if x is 0, right? The number of miles traveled is 0. So now we solve for that. Y equals 16. That whole thing goes away. Okay, so our y-intercept is the point 0, 16. What does that mean? So if we come back up here, y is the number, relates to gallons of gas y. So if y is the gallons of gas, that means a full tank of gas is 16 gallons. Right? So we've kind of figured out is if you go to the gas station and fill up this car, whatever it is, you can put 16 gallons of gas on it and you can travel a total of 320 miles. Okay? So that's helping you remember the x and y intercept. Okay? Now, we're going to switch to talking about when functions are negative and positive. So remember, the whole point of this little lesson is just to remind us different things about functions. So x squared minus 9 is a quadratic function. I'm going to use Desmos to graph it. So you can see, I just put it in my phone here. There's x squared minus 9, the function from the problem. I'm going to take that down. Here's the parabola. So the question says, when is the function negative? So this one is not too hard because they're giving us the graph. They told us to use Desmos. So when is this thing negative? Well, I can quickly see here below the x-axis is when it's negative. And if I zoom into this, I can see that that point there is -3. I'm just going to draw that. So it intersects here at -3, 0, and then it intersects over there again at 3, 0. And it goes all the way down to, it looks like -9. 0, -9. So I'm just going to quickly sketch that. So it's negative all down here. So how could we write when it's negative? So we could say the function is negative, and we can use interval notation to say -3 to 3. I'm just going to put here on the interval. Let's squeeze that in. -3 to 3. You could also say, you could also use the set notation here and say the function is negative is when x is less than 3 and greater than -3. You could also say that, right? So you could say either of those things, what I wrote in the red or the purple. And when is it positive? Just to write the opposite, we could say the function is positive on the interval -infinity to -3 and 3 to infinity, right? So on these ends right here as it's going up, which I didn't sketch, is when it's positive. Not too hard to do, especially if you have the graph. Okay, so that's another vocab word you have to remember. And then the last, one of the last vocabs you're going to have to remember for this is, let me get my Post-it, move it over, is if a function's increasing or decreasing, right? So when is it going up? When is it going down? Scoot that over. So here's the function. 2 take away the absolute value of x. It says g of x equals 2 take away the absolute value of x. When is the function decreasing? So when is it going down? So if I am not going to use Desmos for this, what I could do to make a quick sketch is to just make a table, right? So let's just plug in this stuff. So if I plug in, I just picked some values here, -3 to 3. If I plug in -3, what does 2 take away absolute value of -3? Well, that's 2 take away 3, that's -1. -2 take away absolute value of -2 is 0, right? And hopefully you guys can remember this. I'll write this one here in case you want to see all the steps that I'm doing. So this is just 2 take away, and I'm plugging in absolute value of -1. It becomes 2 minus 1, that's 1. Okay, plug in 0, 2 minus 0 is 2. 2 minus 1 is 1. 2 minus 2 is 0 again. And 2 minus 3 is -1. Okay, so those are our y values. So then I can come over here and plot it. So let's do that. -3, -1, -2, 0, -1, 2, oh, and -1, 1, sorry. -1, 1, 0, 2, and we're just going back down. 1, 1, 2, 0, 3, -1. So there is our graph, right, of points that we plotted, and we're going to assume it continues. And if you guys remember what absolute value functions look like, this, they have this sharp V, so that matches my intuition. So now if I have to figure out where is it decreasing, so we're looking at where the slope is going down. So I can quickly label that on the graph. Here, the function is decreasing, which means on this side, the function is increasing. So this is just to remember to those vocabulary words. This point right here, this point at 0, 2 is the maximum. So if I had to answer this question, when is the function decreasing? The function is decreasing on the interval from 0 to infinity, right? So that's how we could write that. So hopefully some of this stuff is coming back to you quickly. All right, last thing we're going to talk about is average rate of change. So average rate of change, funny enough, I just made a video about this for calculus, so you guys are getting ready for that. Average rate of change is just another way to talk about slope, really. It's the slope of the line segment between 2 points. So here, if I look at this, it's a constant function. So what is the slope between this point, let's call this A and B? You guys hopefully remember that the slope of a horizontal line is 0. So that means the average rate of change is 0. And I'm just going to abbreviate that, right? It's a constant function. And what about this? This is a, hopefully you remember, a linear function. And hopefully you remember y equals mx plus b, right? That's not going to go away. So if I have to find the average rate of change, so how is this function changing between points A and B, I just need to find the slope. And hopefully you remember that to do that, you just do y2 minus y1 over x2 minus x1. And so in this case, that would be 5 take away 3 over 5 take away 2, which ends up being 2/3. So the average rate of change for this second function is a positive 2/3. It's just finding slope. Okay, and then sometimes, I'm going to switch pen color so I don't get all squished in here. Sometimes you'll have a function that's not a line. But let's say we have to find the average rate of change between these 2 points A and B. So we're just going to pretend that there is a line going through those 2 points. So this blue line I've done here. So to find the average rate of change between A and B, we have to find the slope of this line that's connecting these 2 points, right? So that's just the same as we did here. We're going to do y2, which is 4, minus y1, which is 2, over x2, which is 5, minus x1, which is 3. So the average rate of change between those 2 points is 2 over 2, which is just 1, a positive 1, okay? So nothing new here, just remembering that you can apply it to different types of functions. So that's all the new stuff I'm going to give you today, or review stuff. And then you'll also notice that on the assignment today, I posted an image of this from your textbook. Let me zoom out a little bit. So it's just this concept summary, because one thing you're going to have to start to know are these types of functions and generally what they look like. So linear, you guys know. Quadratic, if you don't, we talked about it a little bit today, so review this stuff. Absolute value, same thing, review this. And then constant, I think, is pretty obvious on how that is, okay? So I'll see you on the next video. Bye.